Okay then, so the Great Pyramid, let's get serious with this. Now, it's very nice, very cool how the ideal measures, which are not strictly speaking absolutely 100% correct in regards to the known survey. So on the southern face, this would be true by definition, 440 by 280 Egyptian royal cubits high, which gives us a very close approximation of phi and a very close approximation of pi. However, these is sort of rounded off, and so let's go to the J.H. Cole survey, and all other surveys since basically have the same thing. So we're talking fractions and margins of a hair's length, but each side of the Great Pyramid has a slight variation in it, and this is what I think. Well, it is typically rounded off, and I don't think that serves the purpose as good as it should, because we should be looking try and be as accurate as we can, rather than a lot of the majority of the stuff out there anyway. So J.H. Cole survey, all later surveys basically reinforced exactly what he's saying here, slight variations on each side. And why is that important? Well, because it actually provides something of a map of what the Great Pyramid, the textbook in stone, and the many levels of knowledge encoded within. And for instance, there's a bit of a map. So here we have the south axis and the north axis, and so let's look for, let's begin from, okay, let's pick that one, reduce it, and we'll take this one away. Okay, so in regards to the phi proportion of the Great Pyramid, on the eastern side, using as exact measures as we can, what we get is that this eastern face gives us the closest proportions of phi as a proportion. However, this southeast corner will also point us to some important information. So by that I mean including the subterranean, the southeast corner as a proportion gives us phi squared, and so close that the minuscule margin of error within the survey data would bring us like so close, or to that actual exact perfect point of phi. Now, so the southeast corner represents, including the eastern axis, represents perfect proportions of pi, phi squared, as well as pi. And so again, using the measures as best we can, southeast, maximum visible base. The pyramid is a three-dimensional object. It's not a two-dimensional object. It's not on a piece of paper. It's an actual structure of stone. We need to look at it as a structure of stone and move away from, and this research, previous research has led me to this. However, people are rusted onto it, and we need to move away from it and look at it in a more, because this is not only more elegant, it actually will point us to some much more brilliant, perfect, beautiful systems of knowledge as it's encoded in the Great Pyramid. So the southeastern corner proportion of phi, and we also have the proportions of phi squared, including the subterranean, and we also get phi through the eastern axis. Now, they are proportions, so what's really, really cool is that, so what I'm saying is that the southeast corner represents perfect proportions. However, if we move to the southwest corner, and let me get these. Okay, so the southwest corner of a Great Pyramid, and in this diagram here you can see I've drawn a ruler, because in measurement, and strictly speaking measurement, what we get is, well, there you go, like pi, the meter, the cubit, and the second are intricately related. The pendulum, this is not, this is not even cannot really be disputed. The meter, the pendulum are connected, and therefore so is the sacred, the Egyptian royal cubit of old times. Now, you'll also find it in, well, again, Egyptian royal cubits. That points us back over to the southeast corner. So what we see here is if you take the height minus the base, or the half base, 115.182 meters, we get pi times 10 meters. The proportion here, where we see the maximum visible base minus the height, we get pi times 100 meters. And again, it's so close, well within acceptable margin of error. Now, on that same, now we remove that. Okay, so on again the southwest corner as a measurement, where you see the same thing happening again, where we're getting phi squared times 100 meters. The southwest corner represents measurement. The southeast corner represents perfect proportions, and we can take that further now. I'll just remove that one. Okay, so now let's look at the axis. Southeast, remove, and okay, so there. Now, so if we look through the east to west axis, on the eastern side we have pi proportions, so close, and again using the actual measurements. And okay, before I leave that, let's go back to in regards to pi and proportions. So that's the southeast. And what we have is, okay, what I'll do is I'll push this one up. The Grand Gallery as a proportion. Now there's more, well, if you look at the proportions of the King's Chamber as well, so the perimeter is pi times 10 meters, but the Grand Gallery times pi equals the height of the Great Pyramid. Everything that's on the outside of the pyramid is repeated on the inside of the pyramid. Any chance of coincidence or luck is simply removed. It's a dogma, it's a religion to say that it isn't, because it's just based on pure assumptions. It's not based on measurement or observation or anything like that. So everything that's on the outside is on the inside as well. Now, if we go back to this axis, okay, so what we have, the eastern side, the eastern axis, we have phi as a proportion, while on the here we have like height plus the base apophthegm, phi squared times 100 meters once more. But also as a proportion, what we have is 1.273236, which is so close to the again within a sliver or a hair's breadth in regards to measurement. Measurement's always a little anyway. What we have again is the area of a circle in the square, but also the angle in tan, 1.273. So again, everything that's repeated once is repeated multiple times. It absolutely removes any chance of coincidence within this particular pattern. Again, it's a religion, it's a dogma, it's based on assumptions, because it's on Wikipedia or some guy with an arts degree who doesn't understand these basics, as and he's somehow proclaimed to be a expert on ancient Egypt because, well, he has an arts degree. Now, in regards to phi, so the northern axis of the Great Pyramid, and I'll bring it over here, slight variations on each side, but what do we have? Phi squared. So the northern axis represents phi squared. Again, the typical descriptions of this, and it's still very cool. I'm not saying it's not, but when we use these types of measurement and proportions, these are idealized. They're not as accurate as we can be. And so this is nice, but this is much better because again, we're using, we're being as accurate as we can, and therefore it makes it much more profound, and also points to the fact that there is a whole bunch of, we don't need to sort of round it off. Here is the pattern, here is the plan, here is the measurements. It's a textbook written in stone. Southeast corner, and the eastern represents the proportions, and as we move around we get measurement, the measures. Southeast represents proportions, southwest represents measurements in meter, and the meter, the second, and the cubit are intricately linked. There's no doubt about it. It's just dogma, built-in assumptions. Now, in regards to the geometry, so just the last video I showed how as we move to the northeast corner represents geometry, not just in one dimension but in two dimensions: the circle and the square, the cube and the sphere. And the ratio of the cube and the sphere is exactly the same as the ratio of the Egyptian royal cubit. So a 1 meter diameter circle with a hexagon on the inside. Each part of that arc is by definition one Egyptian royal cubit, which is again this other set of connections. But staying on this 1.273, the ratio of area, a circle and a square, 1.2732. What else do we have? Sheer coincidence, sheer luck. What we get is, well, 1.273239 is 4 over pi. That's the area of a circle inside a square, and the inverse angle 38 there in tan is pi over 4. Same thing's happening over and over again. And well, again, there's a lot more to this. This is just what I've prepared for the moment, but we have proportion, we have measurement, the meter and the cubit. And just as an example, I've done it many times, but the northeastern corner, this is why I've drawn a clock, is because it represents astronomy. And I'll do that in the next video because we have the proportions of the Earth and the Moon. Again, not rounding them off, using the most accurate measures that we can. So that particular diagram there shows a representation of the Earth and the Moon in relation to size, as where the northeast corner, here with the clock, represents perfect proportions of the Great Pyramid in regards to the size of the Earth. Forget this 432 stuff. Again, it's very nice. It's what sort of led me, how I got interested in it. But using a pendulum, the second, and the Royal Egyptian cubit, including the socle and the sockets, again using the actual measurements, not rounding them off or missing information out, what we get is perfect. So perfect that it's well above acceptable margins of error within modern schools. Everything that's on the inside is repeated on the outside. Everything that's on the outside is repeated on the inside. It's what can be measured, and we don't need to rely on ideal measures. We need to rely on exact measures. And so with that, hope you enjoyed. Have a good one. There's a lot more to this. Cheerio.